Okay, this is the app I like to use, but never mind, let me start from zero. Okay, some of the apps that I always use, let's say, okay, search a site. This is, okay, one of the app you can download this from the Android, this Android version. So if you can see here, this is the version that I have, but actually you can adjust this wording here because I'm old actually, so this wording here is quite big. So actually, first and foremost, you can select whether you want to change to IP, which is actually this, or you want to work in SI mode. For me, I'm always doing IP because I am more familiar with American base. So most of the time, the app that I use would be actually, I will find out, let's say I want to design to 77 degree Fahrenheit, and let's say I want to design to 50% humidity. Then the data that I need to use is here, which is the humidity ratio. Wait, let me do this. This is actually this thing here. This is the data that I use. Okay, let's say no more. And I can change this to grains, which is always what I use, grains per pound. You can just change it. Or let's say if I want to, I have a cooling coil. My cooling coil, actually I am designing my air to be, supply air to be 55 degree Fahrenheit. So normally at the cooling coil is almost like 100%, it could be 95, 98, let's say 100% saturation. I can find the grains, it will be 64.3, 64 grains. For doing calculations for swimming pool, this data might be what you need to use, this partial vapor pressure. Okay, okay, this is what you might actually need to use, partial vapor pressure. So those are the things that we use. Then okay, I will show you another app that I always use. So let's close this. The next app that I use is this. Okay, let's say search. Sometimes I use this duck. Okay, this duck app, if you use it, all these things is sorry that this thing is here. I'm not sure whether I can move it. Yeah, I can move it. Normally I would use a pressure drop because I use an equal friction to size my duct. So I select a friction that I want. Let's say is normally I will do is 0.1 inch per 100 feet if I'm not wrong. So you select the air temperature that you want. Okay, first foremost, sorry, you go to setting, you can select your duct, your altitude, whether feet or meters, CFM. You can also change to liters per second, meter cube per hour, and then head loss. All this you can change, okay, in your settings. For me, I'm using imperial. This suits me fine. So let's say I'm designing 27 degree Fahrenheit, 50% relative humidity. Let's say it's a sea level. Let's say my flow rate, for example, I want the flow rate to be, let's say I'm designing the flow rate to be 600. Okay, 600 cfm. Then here you can see the head loss here. Okay, this thing here, you can actually see the head loss. This is the head loss because this is too big, the head loss. So actually what I want to do is that I want to increase the size. So let's say I design it to like width is about 12 inch. Then I can size it up to, let's say 12 inch. I have a 0.051, so it's still maybe still big. Maybe I want it, if I'm not wrong, I think it's a 0.1 inch, so this is too big. So I can size it down. Maybe actually I can have it to be 8 inch. So I have a 0.1, which is quite good. So I change it to 10. 0.08, which is good enough. Or I can use 9, which is 0.1, which is what I want. So you can actually size the duct using this. and the rest I think you can find out for yourself. This is the purpose is just to show you some of the apps that you can get from Handphone. So we will close all. I can close this. Okay, then the next thing that I want actually is I'm going to show you how to use my Danfoss. I like to use this Danfoss calculator. So this actually is a refrigerant slide. So actually you have on the left hand side you have the bar and versus degrees Celsius. If you are working in imperial, you can actually change the unit. I think it's in setting if I'm not wrong. So you can change the setting, whether your pressure, what your pressure is. So never mind, I maintained it in pressure, all this thing, and in degrees Celsius. Distant unit, maybe I can put it in meter. So I'm okay. This is the setting that I want. You can also log in and things like that, but I'm okay with this. Wait, sorry. Okay, I'm okay with this. Then I'll go back to the slide rule. So on the left hand side, actually what you can see is that you actually have your slide rule. So here actually what you have is actually you have a bar on the left hand side, and then you on the right hand side you got degrees Celsius. So for example, let's say my evaporator is 5 degrees Celsius. Okay, I can also key in here. So let's say my evaporator is at 8 degree, maybe 5. I design it to 5 degrees Celsius. So I can change here to 5 degrees Celsius, and then this you can change the type of refrigerant. So let's say I'm on R410, let's say I'm on R32. Okay, so I key in R32. Okay, I use this, and R32 select. So this is R32, as you can see here is R32. Okay, and then here actually you can choose your pressure, whether you want it to be gauge or gauge pressure or absolute pressure. So sometimes I use gauge, sometimes I use absolute pressure, but when you want to test something, it's always gauge pressure. Okay, this is gone again. Then this one, there is some info on the type of refrigerant. So R2 is A2L, GWP is 675, there's no ODP, critical temperature is 78, so don't operate more than 78 degrees Celsius, or else you reach the critical temperature. It can boil at very low temperature, that means you can use this up to very low temperature. Let's say your evaporator temperature is 5 degrees Celsius, so the pressure you have is 8.5 bar. So expect that your suction pressure for your refrigerant is 8.5 bar. Okay, if you want to test pipe all these things, normally you would test it to the condenser. Okay, the condenser pressure. So in the condenser, let's say you are operating at 35 degree, your refrigerant is at 35 degrees Celsius, you are actually at 20.89 bar. So when you pressure test, maybe you could actually multiply, you could actually pressure test it to 20.89, then maybe you can multiply to about 1.1 or 1.2, or if you want to go is 1.5. So there's one thing that I want to point out. So do not always assume that 35 is your what. You know that your condenser actually operating temperature is dependent on the ambient. So let's say if your ambient is like very hot, about 40 degrees Celsius, so you would expect that your condenser would be at you will expect that your condenser to be higher than 40 degrees Celsius. So let's say about 45 degrees Celsius, about 10 degrees. So you can see that actually you're operating at 26.9, which is about 27 bar. That's why in general I think we test it up to 40 bar, the pipeline, but that is also dependent on the manufacturer, whether the equipment can actually be tested to 40 bar. You need to check on that. Okay, so here if you want it to be in you don't want it to be in bar, you can also change this thing. It will give you in absolute. So in absolute, actually you will be adding 1 bar, because 1 bar is the atmospheric pressure. Then you can try this thing here. So if you do the dew, I'm not sure whether I can do this. Dew, I cannot do this, so I'm not sure what this dew thing is. So okay, so this is what you have. Okay, so I think that's all for the refrigerant, all these things. But there are a lot of interesting apps that you can use. Not sure whether I got another app. I think this app is actually from climate something, I think dry air. I have not tried this app really, but let's explore it. Okay, first time here, you can go through the tutorial. So actually there are a few things that you can use. So the psychometric calculator is the same. Here you can key in like the same. Let's say ours is 92. Okay, let's say you can key in here 81. So I want to find out what 92, 81. So I want to find out what grain it is. So here I would actually have I have a dew point. So wait, 92, 81. Done. So this will give me my altitude 0. It will actually give me doesn't give me grains, which actually I want. Okay, it gives me 143. So this is always what I design it to be, 143 grains. Let's see whether just now remember the psychometric chart calculator, all these things that we have, the previous one, it doesn't allow me to key in the humidity ratio. Let's say I want to key in the humidity ratio. This is more cool. 143. Done. It will give me my temperature, all these things, and relative humidity 62%. Okay, let's say I want to design, let's say 77 degree Fahrenheit. Let's say if I'm required to design this humidity to be like, let's say 70 grains, I can do that. So that means my relative humidity is 50%. So depending on what your input is, it can, in terms of relative humidity, wet bulb temperature, or maybe even like a dew point. Dew point is interesting because you can see that the dew point here is 57. So any surface that is colder than 57 degree Fahrenheit, all these things would actually have condensation at this with this scenario. So this is a good app to use. Let's see whether you can try HVAC formulas. I'm not sure. Let's say we'll do the mixing. This is interesting. Let's say you mix outdoor air with return air. So let's say my airflow volume is actually 1000 CFM. So of that 1000 CFM, my dry bulb is 92, 92, and then humidity is 143 grains. Let's say the volume that I have here is maybe 150 CFM. Done. Then the remaining of the air would be like 850 CFM. Let's say this year you put in your design condition, your return. So let's say my design condition is 7 degree Fahrenheit, 70 grains. Okay, like we have just now. So my mixed air, this will be the mixed air. So the mixed air actually is my on-coil condition for your AHU. This is quite an interesting app. And if you are lazy to calculate, otherwise you can just use my Excel sheet. Lead time view, I'm not sure. Let's see what you can do. HVAC formula. So okay, this is actually if you need I've not really used this before, but you can try it. Let's say I have a room size, okay, let's say 40 feet by 40 feet by 10 feet room size. Then I require 20 air changes per hour. And then total volume, it will calculate. So what it will give me actually would be the total volume is 16,000 cubic feet, which is 40 by 40 by 10. Then fuel rate is this cubic feet per this cubic feet. Total volume fuel rate adjustment, I'm not too sure. If you actually have any fuel rate, I think you can put it in. I'm not sure what is the fuel rate. Complete air change is every 3 minutes. At 20 air changes every 3 minutes, you will be actually changing the air totally. Volume required per hour is 320,000 cubic feet. CFM is 5,333. So this is what you can calculate, which is quite useful. Dehumidification capacity. So this one actually is just give you the grains per hour. So it's nothing much to do, because it's just using, let's say you have CFM, then you have your CFM going in at what grains, and then your design room condition at what grains, so it's your delta grains. Okay, so let's say if you are actually moving outdoor to an indoor that is very dry, so it could be something like 80 grains. Okay, so 80 grains per pound, you calculate the one, it will give you need to remove 360,000 grains in 1 hour. I'm not sure, this would be quite nice if you can change it to liters per day and things like that. This would be required supply air humidity ratio. So if the supply air flow rate and indoor humidity ratio are fixed, how dry does supply air have to be in order to remove a non-internal moisture load? This is a bit like cooling. So let's say if I need to remove but you will need to calculate from here first, this grains per hour. So let's say I need to remove 360,000 grains per hour. I put in here 360,123. Okay, I'm done. CFM is 1000 divided by 1000. This is something that I'm not familiar with yet. So it's grains per pound, grains per hour divided by 4.5 multiplied by CFM. So it will give me is back to 80 grains. So how dry does the supply air? So my supply air needs to be 80 grains per pound. This is something that I'm not familiar. It does look funny, but anyway, you can explore this thing. This one is something that I have not actually used yet. It could be quite useful, but I think it is a bit premature for me to go through it here actually, because I've not really used this yet. This is a new app. It does look that it's actually quite a powerful app. Okay, so that's all for now.